So that's what I've given, slope of line joining 2 points. I've already given it to you. So since now you know, if a straight line is given and 2 points on those straight lines are given, you know how to find the slope of that line, right? Now the next point that we are supposed to know before knowing differentiation is, not all the shapes in this world is only going to be a straight line, right? See, what if you have a shape like this? For this kind of a shape, is there a possibility where you can define the slope for it? Yes, you can do that. You can do that, provided you need to draw something for it. I'll tell you what that something is. Okay. Before that, I need to explain you the concept of something called as functions. So I'm going to explain you what is a concept called as function. I'll simplify it as much as possible. Okay. I'm not going to give you more technical definitions or anything. I'll just give a simpler definition. See, in your lower grades, if I give something like this, P of x is equal to 2x square plus 3x plus 1, right? Something like this was given. What is this? Basically, it's a, what polynomial is this? So it's a quadratic polynomial, right? Now, if I ask you, what is P of 2? What will you do? Wherever x is there, you will put the 2. Right, you will just plug in that value and tell me a number. No, 2 into 2 square plus 3 into 2 plus 1. So how much are you going to get? 4 into 2, 8. 8 plus 6 plus 1. It's going to give me a 15. Means the value of this quadratic polynomial at 2 is 15. Right? Or if I put x is equal to, I'm getting 15. Now, can you tell me what is the significance of this? What is the mathematical significance of this kind of a value? You used one word. You called it as a quadratic polynomial, right? So if I take this and draw it on a graph sheet, if I take this expression and plot it on a graph sheet, what does a quadratic polynomial give us? Quadratic polynomial is not a straight, it's a parabola. So ax square plus bx plus c is a parabola. So when I talk about parabola, you can either have an upward parabola like this or a downward parabola like this, right? So when will you have an upward parabola? When the coefficient of x square, that is a, is greater than 0. When will you have a downward parabola? When the value of a is less than 0. I hope it's clear, right? Now tell me one thing. Find the discriminant of this and tell me, is it coming out to be 0, positive or negative? What is the discriminant of this? B square minus 4ac. So b square is 9 minus 4 into 2 into 1. So what is it? It is 1. It's a positive value, right? So positive value means it is going to have 2 real and distinct roots, right? I'm not concerned about roots. Suppose I say the graph is like this. I'm not getting into the details of whether this is right or wrong. I know that there are 2 roots. I don't know where they are. I'm not bothered about it in this context. Okay. Now, if I have a point 2, 0 here. Why did I take 2, 0? Because I took the x value as 2. So, if I drop a line like this, a vertical line like this, then this line is cutting this parabola, right? Then the coordinate of the line where this line, the coordinate of the point where the line cuts the parabola is given as 2, 15. See, this is 2, 0. I'm just dropping a vertical line. Why did I drop a vertical line? Is because I need to know how much is the distance from the x-axis. So this line is cutting this parabola at a particular point. So what is going to be the coordinate of that point? It will be 2, 15. How did I tell that? Because when I substituted 2 in that equation, this equation is basically this graph only. Theoretically, it's an equation. When you draw it on a graph sheet, it is the shape. It is going to take the shape of a parabola. Am I clear with this? So, for this shape, at the point 2, when the x coordinate is 2, what did I get the corresponding y coordinate as? 15. Suppose I have p of 1 What is the answer going to be? So 2 plus 3 plus 1, how much is it going to be? 6. For example, like I don't know where that point is. Suppose this is 1, 0, random points. Okay. Then what is the meaning of this? If I draw a vertical line, then the vertical line will construct a point which is going to give me 1, comma. Am I clear? Are you able to visualize what is the meaning of the values you had been finding till now? Right. Similarly, when you have a cubic polynomial, right, then for that shape, you substitute the value of x, right? You will get the corresponding value of y. End point meant this one. This one. Okay. This distance is what you're asking. Okay, this one. Okay, these are the two ends. You're talking about the roots. You're talking about the roots, right? Because it doesn't have an end. Parabola doesn't have an end. No, it will go to infinity, and this side it will go to infinity. No ends. Is that what your question is? Okay, it's not between the two ends. I thought ends means you're talking about roots. No. This one goes to infinity. This one also goes to infinity. Means you can never find the end point on the graph sheet. Am I clear with this? Right? The significance is clear. Now, what do I have to do with this in terms of function is what the question is. So you learned this p of x, right? How do you pronounce it? You call it as p of x. No, this is polynomial of variable x, polynomial of one variable. That is, the variable is x. In a similar way, if I write y is equal to f of x, right, then I will call this as a function where this will be a function of one variable. As you keep changing the input variable, you will get different outputs. Meaning, as you keep giving the value of x inside, you will be getting the value of y, so that you can plot something like this on the graph sheet. No, because see, the left side, right, what will be the least value that you can substitute on the real number? Minus infinity. So when you substitute minus infinity, right, the value will go to plus infinity. Because minus infinity the whole square. Minus infinity means I'm talking about a very big number. The square of that is going to be even more big. So this value is greater than this. So this will lead to plus infinity. This side also will lead to plus infinity. That's the reason. That is why it doesn't have any endpoints on the sides. Okay. So am I clear with this? Now, see, I've just given you the basic definition of what is function. I didn't even give you the definition. I told you what is a function. Basically, you write it as y is equal to f of x, where y is called as the dependent variable, x is called as the independent variable. Why do we call it as independent? Is because we are free to substitute the value of x. Nobody says you can keep substituting the value of x. For that, what will happen is you will get the corresponding values in the y. Okay, this is what a function is. So basically, a function behaves in such a way that you give one input, you will get one output. You're able to understand? So input is given as x, output is taken as y. So depending on what kind of function you're defining, you will be giving a prefix to it. For example, this in your 9th grade, you would have learned it as polynomial. But in your 11th grade, you will learn the same thing as a polynomial function. Is that clear? So instead of f, you have p, but x is the same. X is a variable. Instead of x, you can use z also. It's up to you. But in common notation, we use y and x as the combination, where y is taken to be the dependent variable, x is taken to be the independent variable. This thing is very important for you to understand differentiation. Again, I'm repeating it. Is that clear? See, suppose, what did I call this as? What function is this? Polynomial function. It's a polynomial function. See, last year you would have learned sine theta, right? Instead of sine theta, if I write y is equal to sine of, in the place of theta, if I replace it with x, sine is what kind of a variable? It's a trigonometric variable. So that is a prefix you need to add. You call it as, so instead of theta, if you write it as x, this is called as a trigonometric function. Similarly, y is equal to tan x. This is a trigonometric function. That's it. Okay. that angle is variable, if that angle is a variable, okay, then so if one value depends on the other, then it is said to be a function. So that you give one input, you take one out. Independent means, see, for example, y is equal to 2. This is also a function. You call it as a constant function. Because, why do you call it as constant function? Because this side there is no variable, it's a constant value. 2 is a fixed number, you call it as a constant function. See, in your 9th grade, you would have had this question. Is 2 a polynomial or not? Is 2 a polynomial? Yes. Why do you call it as polynomial? You can write it as 2 into x power 0. It is a constant polynomial, but still it is a polynomial. Similarly, the polynomial is replaced with function when you come to 11th standard. You call it as a constant function. You need not go deep into this. When I come to the concept of functions, I'll explain it in depth. As of now, if you understand this much, it is enough. So basically, if there is a particular mathematical equation given to you, you give one input, you get one output, you call it as a function as of. That is your understanding. Right? So the function can take any shape it needs. It need not be a parabola, it need not be a straight line, it can be of any shape, depending on what function I'm defining. Okay. So having said this,